I'm in a quarry in basalt flows in central New Jersey.
That's Paul Olson. He's a paleontologist from Columbia University's Lamont Doherty Earth Observatory and an expert on these rocks.
These lava flows are about 200 million years old, and they erupted during the splitting of North America and Africa.
The flows were enormous. They run from Nova Scotia to Brazil, and scientists say they might be a good place to store carbon dioxide emissions.
What's really, to me, sort of beautiful and cool is the carbon dioxide comes out of the basalt when it was erupting.
When it was hot lava.
It goes into the atmosphere. Plants absorb that carbon dioxide. Those plants become fossil fuels. 200 million years later, we take those fossil fuels, we burn them, putting the carbon dioxide back in the atmosphere, and now we're thinking of taking that carbon dioxide and putting it back into the basalt.
For storage, ideally you want basalt that's porous and capped off with another rock, Olson says.
This is where the best spot is. The easiest place to see this is right here, where you have the contact between two lava flows. An older one underneath and a younger one on top. And the lava flow underneath is full of holes.
The holes are ancient gas bubbles that fizzed to the top of the lava flow as it was cooling. Olson says these holes may provide a place to store a mixture of CO2 and water. And part of the appeal is that the basalt reacts with the CO2.
It fills up the porosity in the basalt, and then through time, it reacts with the calcium and magnesium silicates in the basalt to produce limestone. And then it's stable forever. By the way, this is basalt in which that reaction has actually taken place, and the space between the pieces of fractured basalt are filled with limestone.
The bubbly basalt is especially promising for CO2 storage when it's been covered over with more rock, like this.
It's these contact areas that make some of the best potential places to store the CO2.
Olson and his colleagues looked specifically at basalt basins deep within the seafloor.
Offshore, where it's buried and sealed by younger sediments.
They estimated one spot off of New Jersey could hold roughly 1 billion tons of CO2. Of course, there's always the small matter of capturing it and getting it down there. For Science Friday, I'm Flora Lichtman.